Good morning, everybody. Thank you for tuning in this morning or whenever you're watching this. Live stream recorded later. Again, each week I just want to tell you that I appreciate you watching this. It is kind of the thing where like, oh, well, I'm responsible for the material. I need to learn it. So, of course, I would need to tune in to the online class and watch the lecture videos and demonstrations each week. Like, it makes a lot of sense, but nonetheless, you get a choice of what to do with your time, and I appreciate it when you are putting in the effort to succeed in the class. Now, first up, I want to apologize for the delay in getting started this morning. It's not something that I normally like to do, but with the weather situation as it is, even though I don't know that it's really borne much fruit in the immediate area here. The college opened the building late today. All of the students, all the classes are canceled for remote learning. So there are no on-campus classes today. Everything's online today. And they delayed in opening the building until 10 a.m. this morning. So I couldn't get to the office until 10 a.m., which, I could have went and popped on a live stream at home. But I'd much rather have just waited until I got here, where I have 600 megabit upload speed and close to a gigabit of download, especially when people are not here on campus very much. So it's a whole lot easier, a whole lot smoother, a whole lot nicer for you all. So we are going to go over some new material today, primarily focusing on inputs and outputs. Because it's, kind of one of the things that takes our code from where we've been working with it so far in Java, from being just a little bit of code to actually starting into turning into some real programs. You're able to accept an input from a user, do some calculations, do some computations with that input, and then pass it back out to the user so they can see what you've done to it. So we're going to talk a little bit about some of this stuff, and I have a big program demonstration that I'm going to do with all of you here in just a few moments. And then, time permitting, if we aren't getting too close to the hour mark by that point, I've got some other stuff that I can talk about as well that kind of adds some stuff on to both the information that we talked about last week with variables and the stuff that we're talking about this week with inputs and outputs. But when we're dealing with inputs and outputs, where we're at with an introduction to Java, one of the ways that we can really think about them is via systems and scanners. Our system class being the class that allows us to output to the console. And that's something that we've been playing a little bit with already. And our scanner class being the one that we use to get our inputs. So, as we approach this, we should start off by talking about our system class, because we've been using this system class, but we don't really know what it does or what it is, like on a theoretical level. But when we see a word with a capital letter starting it off in Java, that typically means that it's related to some sort of class. A class, we can kind of consider a class in Java to be like a library in some other programming languages, or a module in some other programming languages, where we have this file that's already set up within the program that contains a bunch of other code that we can refer to and use when needed. So, like when we look at something that we've done, like system.out.println, well, that's what that's referring to is the system class with the out method with the print line function. And we'll talk more about that hierarchy of our classes and functions and all that kind of stuff in a little bit. But our system is a class that provides methods related to the system. And when we're talking about a system here, we're talking about the environment on which the program runs. Which would make a lot of sense, you know. I mean, we call our, you know, oftentimes we'll call our computers our computer system or a video game system or, you know, something that, you know, one of these electronic things that we can consider a computer, an electronic element that, you know, takes in data, processes it, and gives us an input, or gives us an output, rather. We can consider that a system. And so when we're looking at a system in that sort of way, like, it is sort of critical that we have that understanding of what we're talking about when we're talking about a system, and a system being the environment on which a program runs. Because this kind of works both with our inputs and our outputs. And when you think about the basic definition of a computer that, you know, we talk about in some classes, I think, I don't know if any of you might have had this idea here, but when we talk about the data cycle being the basis of kind of what makes a computer, the idea that we bring in information, process that information, and give an output, whether it's printing it to the screen, whether it is saving it in a file, or whatever. This is what creates essentially the basics of a computer. This is the idea of a system. So when we're talking about a system in that sort of way, it's an environment where our program runs, and where we're programming on REPL, our online IDE. So this is that server environment in which we have the interpreter and the compiler doing its thing on REPL. And it provides us something called system.out, which is something that we've been using already. You've been using system.out. You've been using it since the first module. And this is actually a special value that provides methods for displaying our output. And so what I want to do is I want to kind of show you something. I want to kind of show you a little bit of behind the scenes of how system.out works. And I'm going to do that by writing a little bit of code. So let me open up my REPL here. Let me make it big for you. And let me zoom into my code. So this is what you see, right? When you get into any new REPL, it gives you the main class. It gives you your main method, being the method where, you know, we have to put in everything that we want to execute. And we get the hello world with the system.out.println hello world. And that's what allows us to print hello world to our console. You all have had some experience with that now in the past couple of modules. Well, what I would like to do is I don't want to print out hello world here, so I'm going to delete that out of that line. What I want to do here is I actually want to figure out what system.out is. So what I'm going to do is I'm going to type in here system.out. So I'm going to print what system.out is, because system.out is something. It exists in our program. And so when we go to print it to the console, we should get some kind of data in response. So this is going to give us a look at what system.out really is. And we can kind of see some hints already from our IDE here. But let's run this and see what we get in our output. Java.io Printstream at 6FF3C5B5. So what we have here, right, is we have java.io, io being input, output, .printstream. We'll talk more about what a printstream is in just a minute. And we have a hexadecimal number here that gives us a memory location of where this print stream is. But this is giving us a little behind the scenes look at what's going on when we use system.out. So when you're using system.out.println, or when you're using any of the system.out functions, it's referencing back to this print stream that we have in Java. So what is it exactly that we just saw? What is this print stream? This output indicates that system.out is a print stream, which is defined in a package called java.io, java.input-output. And what a print stream does is it adds functionality to another output stream. So essentially this print stream gives us the ability to print. We can print representations of various data values conveniently, quickly, easily, all to our console. So that's what this print stream gives us the ability to do. Essentially, it's a stream via which we can take data in, pass it through, and print it out in the console. And as we said when we were looking at it there, you saw those numbers after the at symbol. That's the address of system.out in memory, represented as a hexadecimal or base 16 number. So when we're looking at that, it's not incredibly important to understand all the intricacies of that, but it is a good idea to kind of know how this works in the background. That way we have this understanding of what exactly system.out is and what exactly it's kind of doing behind the scenes. And so we've used system.out.println a bunch for various demonstrations and various tests here. So I'm not going to kind of bore you with any more demonstrations of system.out.println. So from here, what I think I want to do is I think I want to move forward, stop talking about outputs for a minute, and start talking about inputs. So let's talk about the scanner class. So the scanner is a class that provides methods for inputting words, numbers, and other data into our programs. So one of the important things that we have to remember here is that in order to use the scanner class, we have to import it before we can use it. Now, we can use the system class. We can use the system class for outputs and not have to worry about importing everything. The scanner class is also built into Java. We don't have to download anything special to use the scanner class. But they don't include the scanner files in every base program. This is an effort to try to keep program size minimal. And so you import these different classes into your projects whenever you need them. That way you're only really using what you need. So when it comes to memory use and all that kind of stuff, you can keep it regulated. Because Java is it's a big programming language. It's been around for a long time. It's got a lot of stuff in it. And if we tried to take everything that's in the code base and load it into every program, even when we didn't need to use it, the programs that we're going to result in here are going to be absolutely huge. And so it's not ideal to do that. Now this import statement, what it does is it tells the compiler that when you say scanner, you mean the one that's defined in the library of java.util. And you'll see more about what that means in just a little bit. But, the basic idea behind it is if I don't import this class, the interpreter, when it's going through and reading the code, it's not going to have a single clue what I mean by the word scanner. It's not going to know what I mean. Because by default, it's not included in the code base that's in a standard program. So that keyword is not going to be reserved. I could use the word scanner for other purposes. However, once I import the scanner class, then my interpreter can read that, understand that the scanner class has been imported, go into the scanner class, see everything that's there, so it knows that when I say scanner, this is what I mean. So it's given context for the words that I'm using in my program. So what I'd like to do is just kind of demonstrate this really quickly. Let me move back over to REPL here. I'd like to demonstrate some of the basics of using scanner so that we can get data from our user. Now, what I'm going to do here is I'm going to get rid of this system.out. We don't need it. That was just to kind of show you something. But I am going to leave that system.out, that print line statement there, because it's smart to do, right? Like, we've already got this successful line of code. So one of the things that I might want to do is use a successful line of code that I already know works in my program. So we can just leave that in there and put some output to it later. So what I'm going to want to do is I'm going to want to use scanner to get an input from my user. We'll make a basic type of demonstration program right now. We'll call this it'll be like a number doubler program. So it'll get an integer from our user, multiply it by 2, and print that result out to the console. And then we'll go into doing a more complicated version of this after we see this minimal proof of concept. Which, by the way, is one of the smart things to do if you're approaching a bigger problem, right, is to try to think about, well, this is a big problem. What would a smaller version of this problem be? So how can I kind of work backwards to get to what we need here? So work from a smaller problem and build up to a bigger problem so you can understand it better. Makes a little bit of sense. Now, one of the things that we're going to want to do here is we're going to want to create a container. We said last week that a variable is a container, and it's a container that we can put data into. And we broke our variable creation process into 2 parts, declaration and assignment. So what we're going to do here is we're essentially going to declare a variable so that we can have a container to put some data into, but we're not going to assign it a value. Because remember, what we're doing here is we're getting an input, so we're not going to define the value of this variable. Our user is going to define the value of this variable. So if our user is defining the value of the variable, we need to be able to establish a container to put a variable into, but we don't need to put a data value in it. And based on what we learned last week, we don't have to. So we said we want this to be an integer variable because it's just a number that we're gonna take and we're gonna multiply it by 2. So let's create an integer variable container. So we'll strict type that with int, and we'll call it number, int number, and add our semicolon at the end. So what we've done here is we've established a container, right? Remember the stuff that we've talked about last week. We've established a container. We've put a label on it. That label says number, but it's empty. It's an empty container. And so what we see here, we see this little green squiggle under our number variable. And what that green squiggle means is that we've declared this variable, but we haven't used it yet. So we need to use it. So every time before you include a scanner statement, you also need to include, well, you know what? I might be getting ahead of myself here. Because we're going to need to create a scanner object. And our scanner object is kind of like a variable. Essentially what we're doing with a scanner object is we're putting an element in our program to say, okay, we're going to be listening for an input, and this variable name here is going to be the reference to scanner that we're going to be listening on. So when I create a scanner object, I'm going to create it like this, and I'm going to need this before I'm going to be able to use it. Because this is basically saying listen for some input. So it's going to be a scanner object. So we strict type that with the word scanner. We can give it some kind of name. Oftentimes you'll see it given the name of like in. But it doesn't have to be in. We can put any name here. It's like a variable name. You know, we're creating an object here. So we're creating an object called in that is a scanner object. And we're going to set that equal to a new scanner object. And then we have to tell it where to be listening on. Since we're dealing with the console here, we're dealing with the environment, we're dealing with the system. Well, we're going to be listening on system.in. So now we've created this new scanner object, which is going to be the word in. So whenever we want to reference our scanner, whenever we want to reference something that gets an input later on, we're going to use that variable keyword in, because that's what we defined here as the object name. And it's going to be listening on system.in. So now, before I get an input, one of the things that I'm going to want to do is I'm going to want to give an indication to my user about what kind of data I want them to input. Because if I just leave the program with kind of a blinking cursor there or whatever, my user's not going to know what to do. So I need to give them some indication as to what they need to be doing now. So I'm going to enter a line, system.out.println, enter a whole number, colon space. And we add that space there at the end, so it gives a little space between the end of this sentence and the user input. So now we can actually take the user input and put it into that variable that we created earlier. So we can say number equals in, which is the name of our scanner object, dot next int, next integer. So that's one of the things that we're telling our scanner. So when we use different programs, it'll be next whatever, next what, next. It could just be next for any type of data. It could be next int for an integer. It could be next double for a double. Next we often use for strings as well. So we might do an example with a string here in a little bit. But this is what's calling that scanner object that we just created, scanner in. And it's going to pass that value into the variable that we created earlier, number. So now we're actually having our user put data into that number variable container, which is smart. So from here, all we need to do is we need to do the thing that we said we were going to do, which is double this value. So we can do this via another variable. We can call this number x2, and that'll equal number times 2. And then we can print out number x2 to the console. And so now we have a program. And we can see something here that our IDE did for us. I was leaving that out on purpose just so we could get back to using to see what happens when we don't have import java.util.scanner. But it came up here and it added it for us. So you know what? I'm going to remove that so we can see what it looks like when we forget to import Java, because I was trying to do that on purpose. But my IDE had other plans, which is, why we're using an IDE, because it's helpful to us, because it's friendly to us. Because when we run this, it's going to throw us a big error. It's going to say, you're using this word scanner. I don't know what that means. Right? We can see that if we read that here, Error cannot find symbol. What's the symbol? Class scanner. It has no idea what that is. So we need to make sure that we're importing scanner in order for this to work. And you kind of saw that statement there, which is going to be import java.util.S scanner. And so once we add that line to the very top of our code, it needs to be at the very top because our interpreter needs to assess it first. Once we add that line to the top of our code, well, now it understands what that is. So we can run this now. Number x2, did I typo? Oh, I know what the problem is. Duh. It's because it's not fully declared. That's what happens when you're programming in too many programming languages in a single semester. That needs to be int number x2. Now we're good. So it's telling me enter a whole number. I can enter a whole number here, which is I can enter 12. And we get 24. Now, one of the things that we see here is we have enter a whole number on one line, and then it has our enter on another line. If we don't want it to be like that, all we need to do is change the type of print statement that we're using to print out to our console. So when we use print line, it prints a single line and prints the next thing to the next line. But if we use just system.out.print, that's going to print on the same line as what comes after it. So if we change that to system.out.print, enter a whole number, run this again, we get enter a whole number, and you can see there my cursor is on the same line as enter a whole number. So if I entered something like 25 here, it's on the same line as enter a whole number, which makes it look more like a program, right? Smarten it up. We hit enter and we get 50. So that's the basics of using that. And, just so you can see another basic example here, let's take this code. Let's refactor it just a little bit. Let's have it do a string instead of a number here, because a string's a little more difficult, because remember we use our string constructor class to create a string variable. So string name, let's say, equals new string. And just like that, we've established our container. So we use the same import statement, the same scanner statement. We'll change this line to be something of more descriptive of what we're doing now, which could be something like what, hit the caps lock key, what is your name? Now here, we're not using our variable number anymore. We're using name. And what we're getting input is going to be a string and not an int. So we'll just use next. Don't need this line anymore because that's not doing anything. And so from here, we can concatenate the value of our name variable with what we have just gotten from our user. So we can say something like, hello. Concatenate that with name. Thanks for joining me. Right, so we can see that, we had to change a few things here to be able to get a different type of data in, right? Because it all goes back to that whole idea of Java being strictly typed. So when we're strict typing our variables and strict typing the data that we're passing in between things, we'll have to, refactor some things depending on the data type that we're using. So we see here on my line 6, we've established a string constructor class that's going to create a container to put a string into. We have the same scanner statement. Just to show you something, we can change this to be whatever we want it to be. We could change it to be tree if we want it to be. This is just like this is just a variable name. The only thing is that when we're referencing this object later, we have to reference it by its name. So now instead of in.next, that would be tree.next because that's what we named our scanner object. It's still going to be listening to system.in because remember that that's the input from the system. That's not changing. The only thing that's changing is what we've called it. So we can run this from here. Let's go ahead and clear out our console of what we had in there previously so we can see this new thing run. And run it. We get, what is your name? I can just type in a string like Mr. Ramsey. And we get, hello, Mr. It didn't like the space because the space is there. So we should probably do this again and just use like a name. Like, hello, John. Hello, John. Thanks for joining me. If we wanted, let's see, what is the whole thing? It would be next line for the whole thing. So tree.nextLine. So if you want something that's a little bit smarter, that it'll take all of the data that's input and pass it through back to the string, you're going to use next line instead of just next. Using next stopped me after Mr. where I had that space there. Next line is going to do the whole thing. So if I run this now, what is your name? Now I can type in Mr. Ramsey, right? And it's going to take that and it's going to bring that back into my program as the name variable and print it out to my console. Hello, Mr. Ramsey. Thank you for joining me. So that's the difference between next and next line. So the majority of the time in our programs, we're going to use one of the more specific nexts here. Like next can get you basically anything, right? Because it's not specifying the data type. But if we're smart about things, we need to be using next and data type. So next integer, next double, next line, which is a little bit different from next, like you might expect it to be next string, but it's not. It's next line. That sort of thing. So now what I'd like to do is I'd like to write a bit of a longer program. I'd like to write something that I like to call a rectangle solver. So it's basically something that takes the dimensions of our rectangle and then solves a bunch of things for them, like perimeter and area and all that kind of stuff. So what I'm going to do is I'm just going to go ahead and delete this code that I have in my main method here out. if you are following along and doing this at home, I would recommend that you start yourself a new REPL. That way you have a nice, clean starting point, and you can go back and reference this functional code later on. So I'm just going to delete out this code that we have in here. I'm going to leave in here our our import java.util.scanner line, because I mean that would be the first thing that I would type back anyway. Whenever you're typing something and whenever you're creating a program and you know that you're going to be creating this program with user input in mind, one of the biggest things that you're going to want to look at is utilizing java.util.scanner and putting that in there first. So this should be the first thing that you put in when you know that you're going to be working with user inputs. So from here, we can start to establish some containers, and we're going to create some variable containers here. And I want them all to be doubles, right? Because I'm going to want floating point numbers. I'm going to do some more advanced calculations with these. You know, if you're using some kind of geometric solver in the real world, one of the things that you're probably going to want is precision. So we're going to start at the beginning by setting ourselves up for success by creating these containers and creating them as doubles. So we'll create a double container of side A, a double of side B, a double of side AX2. Let's remember our semicolon. A double of side BX2. A double of rec peri for rec perimeter. And a double for rec area. So now we've established all of these containers. Now we're only going to get inputs from our user for side A and side B. But since all of the rest of our data is dependent on side A and side B, we can't put any kind of values in any of our other variables yet either. Because remember that when our interpreter runs through this program and it starts to compile it, it's going from top to bottom. So if it hits one of these and you have, maybe you have side A times 2, well, it's not going to know what side A is because side A hasn't been defined yet because it's being defined by our user. So we have to do everything here after our user defines the values. And this is something that's critical. This is something that students kind of get confused on every semester. Is that whenever we're working with values, we can't do anything with our variables in terms of putting value into those containers until after we've gotten the values. Which, when you put it that way, it's like, well, you can't do anything with the values until you have the values. That makes sense. It's just something that we have to keep in our minds and keep thinking about as we work with this stuff. And so now we'll create our scanner object. And so we'll create a scanner. We'll give it some kind of name. Let's try U, capital I-N, for like user input. Just to show you that we can put anything here. Most programs you'll see use like in as the keyword here. But this is just to show you that you can put anything here. When I started teaching this class, I would only use in. And students would think that you have to use in, and that in is the code, but that's a variable name, that's an object name, and not something specific. And so we can set that equal to scanner, or it's a new scanner on system.in. And that would be another thing students have a problem with is, conflating this in system.in with the scanner name in being two different things. We can let that scanner name be whatever we want it to be as long as we use that same scanner name later. So I'll tell you what, let's do. Let's go ahead and put a title to this program. So we will system.out.println, and we'll call this, add a little decoration here, the rectangle solver, and have ourselves a little title. Now, something that I might want to do is I might want to have a blank line in here, and we can actually do that a couple different ways. We can add the /n to our program, to our string, and that is a regular expression character, meaning new line. Or we could simply add a system.out.println statement that we just leave empty, and that'll print us a blank line. Either one of those works in terms of giving us a blank line between part of our output and another part of our output. So let's ask our user for our first piece of data. And let's ask our user for side A. So we'll start out with our prompt, because that's what we need. We need to prompt our user for data. So that's going to be system.out.print instead of print line, because we want the user's input and this prompt to be on the same line. Enter length of side A, colon space. And so then we will set our side A variable container to be equal to our UIN, whatever we named our scanner object, dot next double, because we're getting doubles. Remember, we defined these containers up here as doubles. We're getting doubles from our console. We're going to make those match. Even if our user just enters in a whole number, our program's smart enough to know that 2 is equal to 2.0, right? So we don't have to really worry about that. So now, what we want to do here is we want to get the length of side B. So we will system.out.print, enter the length of side B, and we'll do the exact same thing, except this time we'll set it to go into the container of side B. So side B equals UIN dot next double. So now that we have all our inputs here, we're essentially done with our inputs for this example. We're going to do some more with the program. One of the things that we could do here is we could close our scanner. You know, as long as our scanner is open, which happens when we create the scanner object, as long as our scanner is open, it's going to be listening for input, and it's going to be, you know, taking up space in memory. So one of the things that we could do here is we could close our scanner so it's no longer listening. UIN.close. And so that's just going to stop the scanner from listening and kind of take it out of memory. So it's going to make our program a little bit more efficient. But it's not really going to be, you know, something that's kind of required for that. And actually in later programs that we do, we're just going to leave our scanner open and running because we're going to need multiple inputs at multiple times. So now that we have these data values for side A and side B, well, we can start to assign values to our other variables, to that side A x2 and that side B x2 and that rec peri and that rec area. So let's go side A x2, and we'll set that equal to side A times 2, because now we have that value from our user, so we can go ahead and put it into our program. Side B x2 equals side B times 2. And remember, we declared all these up here. right? So we don't have to redeclare them down here. We already have the container established, so we're just putting data into the container. We're just doing assignment here. Rec Perry. Well, that's going to be the sum of side A x2 and side B x2, so we can use those two values now. Side A x2 plus side B x2. That's going to be rec Perry. And then rec area. Well, that's going to equal side A times side B. So based on those two values that we got from our user, we're able to do this to where we can, do the rest of our calculations. Now we have something that's ready for output, right? We've got everything. We got all of our inputs. Now all we have to do is make our outputs. Let's add another blank line in here just to make our program output look a little nicer. So this will be system.out.println empty. And now we can start printing the results of our stuff. So like system.out.println the length of side A. And we can concatenate that with side A and concatenate that with space units. And from here, we make sure we put our semicolon at the end. But from here, since we have something that kind of works already, we can copy this, paste it, just change all of our A's to B's. So length of side A, no, length of side B units. And we could just kind of paste a couple and put the perimeter of the rectangle is going to be rec Perry units. And the area of the rectangle is going to be rec area units squared. And then maybe we'll just give our user just a little thank you. So let's put another blank line here, system.out.print line, and a little system.out.print line thank you. So now we have a complete program here that we've run through line by line. Let me zoom out here so we can see kind of the whole program on one slide or one area, so we can see what we've done. Right, we've imported Java at the top we've imported java.util.scanner at the top because we know we're going to be getting a user input, so we're going to need scanner. We're utilizing our class and our main method that REPL gives us, because we're going to start with using successful code because we're smart like that. We've established all of our variable containers here through variable declaration. We've not put any values in them yet because we don't have any values to work with until we get them from our user. We also have our scanner object here, which is going to tell our program to listen for input. We got a little title of our program. We got a blank line. Then we have a prompt here to tell our user to enter the length of side A. Then we're going to take the length of side A, pass it into the side A variable. So this is where we're assigning the variable that we declared up here. We prompt our user, enter the length of side B. We get our side B variable. So we're assigning data to our variable via our scanner, the variable that we declared up here. We're closing our scanner, so it's no longer listening for input. We're doing the rest of our calculations to finish assigning the values to the rest of the variables that we declared at the top. Then we're doing the output to our user with all of the results. So we can run this from here and we can watch it work. The rectangle solver, enter the length of side A. Well, what if it's 12? Enter the length of side B. Well, what if it's 8? And since, just as kind of a bit of like a logic thing, because a rectangle, the adjacent sides, the sides that face each other, are the same length. So we can work with this like this with just side A and side B. And so once I hit enter here, it's going to do the rest. It's going to do everything else for us. It's going to do the rest of the calculations, spit out all of our output, and give us something that we want. So the length of side A is 12.0 units, length of side B, 8.0 units, length of perimeter is 40 units, area is 96 units. So in this instance, we probably could have used integers, but realistically, like our user could input floating point numbers, so that's why we used floating point. So if they did something like, well, it's 12.85 and side B is 9.53, then we get that precision via our double values there that we might want otherwise. So that's our program. A big program example in addition to 2 little proofs of concept that show us how we can get our data from our users. Let us quickly run through a little bit of other material as we get ready to wrap up here. Because we talked about kind of how things work with the structure of the program. So what we have here is we have that structure of package, class, method, statement, expression, token. Right, so a big package is going to be like our Java util package. That's going to be a huge package that contains a lot of classes. And so our scanner is a class. Our system is a class. We'll talk about other classes as we kind of progress throughout the course. And we said a class contains a bunch of methods. And these methods are like next int, next double, next line, whatever. If we wanted to use this in conjunction with like our system package there, I think is still java.util for system. Might be wrong about that. I haven't gone back and looked at that in a while. But the class would be system. Methods would be things like in and out. Statements are a single line of code. Expressions are, like a computation. And a token would be like a variable name. So that's what we have here. We've got some other stuff that we can talk about in terms of like literals and variables. We can just kind of run through some of that stuff really quickly. Sometimes when you're doing math, you need just like a value that's just a static part of a calculation. And so these are a special type of variables that we call literals. Pi is a good example here. And essentially we just do this, put them into our program as variables, so it's not confusing to programmers in the future. Like they know that what this number is and what this number is supposed to do because you've given it a descriptive name instead of just throwing some magic number into an equation. So this is something that we like to do. In Java, we have something called constants as well, which is something that you might do with a literal. A constant is a variable that cannot be changed, right? So like we've said, like via the process of reassignment, once we can take that container, we can take data, take it in and out. But with a constant, we're putting the term final before the type in the declaration. And so when you put that final in there, what that means is that variable can't be reassigned. It is the data that it is. And another convention that we use in Java is that when we have a constant, we put the name of that constant in all caps. Now, another thing here that I have is about the printf print. So we looked at print and print line in our example there. There's another one called printf, and I think you have some material about it in your Blackboard reading. So you can have a look at that and read that, and we'll use it in some future programs so you can see it demonstrated. We'll just kind of gloss over it right now for the sake of time. But what that allows us to do is it allows us to format elements in our output. So if we have a floating point number that's super long, we can use a printf statement to truncate that floating point number and round it to 2 or 3 places, which is something that we might want to do in the case of like the program that we did here today, where we have something here like where the area of the rectangle is 122.46049999999. Maybe all that precision isn't that important. So we can just we can format it and have it there. So since we've about reached the hour mark here, I'm going to go ahead and stop the live stream for today. I'll hang out in chat for just a couple minutes, just in case anybody who's watching with me live has any questions. Remember that your Module 3 assignments are due this week on Sunday, 11:59 p.m. I'm going to be trying to get all of your Module 2 stuff graded between today and tomorrow. So be on the lookout for that. Again, if you're watching this later and you have any questions, feel free to contact me, Teams, email, whatever's easiest. We'll find that and we'll get you straightened out. We'll get your questions answered. But that's all that I have for you for today. Thank you for watching, and we'll see you next time.